Hello everyone, 大家好啊。So this is my first time to take a video on my handwriting, so I'm a bit nervous. And this video will be very long because I need to integrate this guy. So please be patient. And I just want to advertise myself, like and subscribe my channel. Hello, I'm a bit nervous. Maybe I will conduct this video in English because I don't want to do the translation because it's very long. It's very time consuming. Maybe sometimes I will add some Cantonese, but mostly I will use English. So please forgive my simple English. Okay, so we need to integrate 1 over x to the power of 6 minus 1. And I will break down my steps. And I will explain step by step how I calculate each step, and then I will show all the calculations for you. So at the beginning, I need to factorize this 6th power. So I will use the cubic identity. I will make x to the power of 6, and then becomes x cubed whole square minus 1. And then I will have 2 cubic identity, x cubed minus 1 and x cubed plus 1 dx, like this. Okay, it's clear. I need to look at the computer monitor to make sure what I just write is shown on the screen. So I will use the cubic identity to factorize these two terms. So it will be a little bit longer. This is x minus 1, x squared plus x plus 1, and then x plus 1, x squared minus x plus 1 dx. So we have 4 factors in the denominator, and we need to do the partial fraction to break down each term. So we need to do the partial fraction. And to do the partial fraction, okay, let's write down each term. A over x minus 1 plus bx plus c x squared plus x plus 1. Because the denominator is power of 2, so we need to make a linear factor in the numerator, plus d over x plus 1 plus ex plus f over x squared minus x plus 1. And the whole expression will be equal to 1 because the original numerator is 1. So we have 6 unknowns in this partial fraction. It's okay, be patient. And I will write down each term after the multiplication on the denominator. Then the numerator will have four big terms. The first, second, third, and fourth, I will write them down vertically. The first term is a multiply these 3 terms, and notice that the last 2 terms, x plus 1 and x squared minus x plus 1, they are in fact the x cubed plus 1. So I will simplify the expression like this. And this is x cubed plus 1. So this is the first term. So how about second term? Bx plus c. It needs to multiply x minus 1, x plus 1, and the last guy. So I will still combine them so it makes things simpler. The last one is x cubed plus 1, like this. And then the third one I will continue to write. The third one, we need to multiply the first 2 denominator, which is x cubed minus 1. So I will combine it like this. X squared minus x plus 1. And then for the last term, it's like the second term. I will just write down x cubed minus 1 and then x plus 1. So there are 4 terms. We need to solve each unknown one by one. So the most simple action is, let's go up. Yes, put x equal to 1. Okay, when x equal to 1, the last 3 big terms will vanish, and then a multiply 1 square plus 1 plus 1, which is here, and then multiply by 1 cube plus 1 is equal to 1. So we have 6a equals 1, and a equals 1 over 6. So we can solve the first unknown. And then how about the second unknown? We put x equals minus 1. And notice that if I put x equals minus 1, then the first, the second, and the... Okay, let's see. Okay. And the last one will vanish. So we can solve for d. Yeah. d multiplied by minus 1, and then minus 1 whole square plus 1 is equal to 1. So negative 6d is equal to 1. So d is equal to negative 1 over 6. So now we can solve 2 unknown already. Yes. So how we can proceed? Okay, we will compare the coefficient. So notice that the highest power in these 4 expressions are x to the power 5, because this is x squared. It multiplies to x cubed, so it will become x to the power 5. So for each term, the highest power is 5. So I will compare the x to the power 5 coefficient. So let's move to this way. Okay. We compare x to the power 5 coefficient. This needs some observation. So the first term, which term can give me x to the power 5, is only a, which is 1 over 6. So I can write down here 1 over 6. This is a. And then for the second term, this is b. For the third term is d. For the last term is e. So I can write down like this: 1 over 6 plus b plus d. d is 1 over 6, negative 1 over 6, plus e. Their sum should be equal to 0, because there's no x to the power 5 terms in the numerator. So we can obtain an expression between b plus e, which is 0, and we call this the first equation. So now we compare the constant term. So how about the constant term? Let's move a little bit down. We can see this is a times 1 times 1, and then c times minus 1 times 1, and then d times minus 1 times 1, and then f times minus 1 times 1. So we can write down another equation, which is 1 over 6. Because the c I can see is okay, is a minus c, and then we have minus d. So we have positive 1 over 6, and then minus f, which is equals to 1, because the constant term in the numerator is 1. Okay, so we can simplify this expression. I will move the 1 to the left hand side, and then c plus f on the right hand side. So I can say c plus f is equal to negative 2 over 3. So I call this the second equation. Okay, let's move on. And now we have to compare the other coefficient. Because we compare all the things already, the simplest things. So how can we obtain the other coefficient? So I will use the table method because I don't want to multiply all the things out because it's very time consuming. So I'll make some tables here. So for the first term, I will use a table like this. I will put all the 3 terms x squared, x, and 1 on this row, and then I will put x cubed plus 1, x cubed and 1 here. And notice that we have a, so I will multiply the constant term to this row. So this is 1 over 6. Okay, so I will check the x to the power 4 terms, which is here. 1 over 6 x cubed times x, it is 1 over 6 x to the power of 4. So I can obtain the term with the x to the power 4. So I'll do this for the other table. We don't know b and c, so I will write it here. So the top is the top I need to multiply these 2 terms out, which is x to the power 4 minus x cubed plus x minus 1. So I can put them here. Minus x cubed, don't forget the plus and minus. Okay, here I put bx and then c. So which term can give me the x to the power 4? Here, negative b x to the power 4. Here, c x to the power 4. Okay, good. So I'll continue. Here, notice that we have the d is already negative 1 over 6, and a is 1 over 6. Okay, good. So I will create a table like this. X squared minus x 1, and then x cubed. These are 1 over 6 x cubed, and then is plus 1 over 6. Okay, I hope that is not so messy. So this box can give me 1 over 6 x to the power 4. Okay, for the last one I need to do it here. Okay, give me some space. Okay, I need to expand first, which is x to the power 4 plus x cubed minus x minus 1. So again, I will do the table here. X power 4, x cubed, and then minus x minus 1. And then this is ex, this is f. So this box can give me e x to the power 4, and then this box f x to the power 4. So I can combine them. Let me copy here. we are comparing x to the power 4 coefficient, which is 1 over 6 minus b plus c. I move it a little bit up, okay, so you guys can see. Plus 1 over 6 plus e plus f, equals 0. Okay, so now we can combine the two 1 over 6, which is 1 over 3. We leave negative b here, and then plus e here. C plus f, we have the value negative 2 over 3, which is equal 0. We now have e equals b plus 1 over 3. So this is our third equation. This is good because we have two equations in two unknowns, 1 and 3rd. So we can solve them simultaneously. Okay, so we substitute 3 into 1, which is b plus 1 over 3 equals 0. So 2b equals negative 1/3, and then b is equal to negative 1 over 6. And then we can immediately solve the e. E is 1 over 6. Oh, that's good. We now have to compare another coefficient, which is okay because we create a table already. So I will use another pen, which is a red pen, and I also have a black pen. This video is also dedicated to black pen, red pen, because he did another integral on 1 over x to the power of 6 plus 1, which is very amazing. So we need to compare the x cubed, which is here, 1 over 6 x cubed, and then here no. Okay, and the second table here, negative c x cubed, and then the third table, negative 1 over 6 x cubed, and then the last table, f x cubed. Okay, so we can gather the information, and then I write x cubed coefficient here. So 1 over 6 minus c minus 1 over 6 plus f equals 0. And then we simplify, we just get a simple equation, c equals f, which is equation 4. So this is also good because we have the previous equation. The second equation, c plus s is equal to negative 2 over 3. So this is we sub 4 into 2. So f plus f is equal negative 2 over 3. So f is equal to 1 over 3, and also c is equal to 1 over 3. So we solve all the unknowns in the partial fraction, and then now we can put them back into this guy. Okay, I will do this at the back of this paper. Okay, hopefully I have some space. Okay, we need to integrate this guy, which is equal to integrate 1 over 6 over x minus 1, and then plus negative 1 over 6x minus 1 over 3 over x squared plus x plus 1, and then plus negative 1 over 6 over x plus 1, and then plus 1 over x minus 1 over 3 over this guy. Okay, let's add a bracket here. So I move the number to the front, which is integrate 1 over 6 multiply 1 over x minus 1 minus, I will take out the 1 over 6, the factor, to the front. So this will make the numerator, because I take out the negative, this will make the numerator positive, x plus 2 over x squared plus x plus 1. So I will add a red plus sign here to remind myself. And then 1 over 6 at the front, 1 over x plus 1, this is easy, plus 1 over 6 is the same, x minus 2, x squared minus x plus 1. Okay, so I will add the dx at the back. So these two guys are easy. We know that integrate them is the ln x function. So the most troublesome is this guy, and also this guy. These two guys are very similar. So I will first do the first one. I will take out this one. I will ignore the negative 1 over 6 first. I will first do this guy here. So the second one, we need to integrate. You need to integrate this guy. Integrate x plus 2 over x squared plus x plus 1 dx. When I was young, I always think that, and of course this is the sense of integration, because I want to make the numerator to become the derivative of the denominator. If I differentiate the denominator, which is 2x plus 1, I want to make this to become 2x plus 1. So when I was young, I always think like this. 2x plus 1, I write this down first, but originally it's x plus 2, so I need to minus x plus 1 at the back, and then over the numerator. But this thinking is not working. Yeah, after I got wrong in my test, in my math test, because it will generate another x term here, which is not good. It's not working, because originally we have x already. So if I generate another x, it's useless. So we will do another way by multiplying both numerator and denominator by 2, and then I will split out the term. This is integrate 2x. Originally it's 4, right? But I want a 1 here, so I add 3 at the back, and then the denominator is multiplied by 2 like this. So now I can split the fraction into 2 parts. Okay, let's do this. Okay, 2x plus 1 over this guy, and then dx plus integrate 3 over 2x squared plus x plus 1. So the first one, this is simple, which is 1/2. I take the constant out, and this guy is the derivative of this guy, so it's ln. I will add an absolute sign here, x squared plus x plus 1, and then plus. I will first take the constant out, 3 over 2, integrate 1 over this guy, x squared plus x plus 1 dx. How can we integrate this guy? we need to first complete the square in the denominator. So I will not copy the first guy because it's finished. I need to plus 1 over 2 whole square, and then minus 1 over 2 whole square, and then plus 1 at the back. Because I want to make it to become a perfect square, like this. Okay, x plus 1 over 2 whole square. So this is minus 1 over 4 plus 1, which is plus 3 over 4, and then 1 over dx. So here I will use simple substitution. U equals x plus 1 over 2, and then du equals dx. So I will replace the x world to the u world as the Blackpack website said. This is u square plus 3 over 4, like this, and then at the back is du. Because we have a standard integral here, if we know that 1 over x square plus a square dx is equal to 1 over a arctangent x over a. So I ignore the plus c at the back. I will add that in the final answer. So now a square is equal to 3 over 4. So a is equal to root 3 over 2. So I will integrate this guy. Plus 3 over 2. And then 1 over a. So now we know that a is root 3 over 2, right? Okay. 1 over root 3 over 2. This guy. And then arctangent. And then in the bracket, u over root 3 over 2. This guy. I will not add the plus c here. So now I don't have space. Oh my god. Okay. 2 over root 3. I reverse the denominator. Arctangent. And then we replace the u by x plus 2 here. X plus 2. X plus 1 over 2. And then this guy should be multiplied by 2 over root 3. Because I reverse the fraction. So this guy I cancel out. This guy I cancel out to become root 3, which is plus root 3 arctangent. And then I will multiply this whole expression to 2, which is 2x plus 1 in the numerator over root 3. This is more simple, I think. And then of course I will not forget this guy. Come on, baby. So I will copy all the things here. So now I have the answer. This is equal to 1 over natural log absolute x squared plus x plus 1 absolute plus, I will copy down this guy, which is root 3 arctangent bracket 2x plus 1 over root 3. Okay, we finish the first guy. This one, we finish the first guy, and then we will go for the second guy here. This guy, they are similar. Okay, it's very similar procedure. So I'll do on the other paper. I will. Okay, wow, I touched the I touched the lamp. Okay, integrate x minus 2. I hope that the computer will not become out of order, because I think it's very hot now, the computer. So I'll use the similar skill. Integrate both numerator and denominator we multiply by 2 dx. Okay, now we need to split the term. This is 2x minus 1 minus 3, and then the denominator we keep it. Okay, now we split the integral. 2x plus 1 over 2x squared minus 1 x squared minus x plus 1 dx, and this guy we minus integrate 3 over 2 this guy. Okay, so now this guy is 1 over 2 natural log x squared minus x plus 1. And then for the second guy, we do the similar procedure. So I will do the complete the square quickly. Minus 1 over 4 plus 1 dx, like this. And then I proceed. Okay. Integrate. Okay, this guy. Okay, 1 over x minus 1 over 2 square plus 3 over 4. So it's very similar to the previous one. We let another v equals x minus 1 half, and then dv equals dx. So we can replace the whole thing with 1 over v squared plus 3 over 4. So we apply the same formula. Dx minus 3 over 2, and I will integrate directly. 1 over root 3 over 2, the whole thing. Arctangent v over root 3 over 2. Phew. Oh, this is very clumsy. Root 3, I will simplify like the things before, so I will skip some steps. V is 2x plus 1 after multiplication with 2 over root 3. Oh, so now, okay, let's do this. I will copy this answer back to the original equation. So I fold the paper first. Oh yeah. So now originally I have this guy, and then I integrate the two answers here. This one is the first one. So I'll gather the information and put all the things into the solution. So now integrate 1 over x to the power of 6 minus 1 dx is equal. Okay, we do this one by one. This guy, which is 1 over 6 natural log absolute x minus 1. And then, how about this guy first? This guy, negative 1 over 6 natural log x plus 1. Okay, so this guy and this guy we cancel. So now here we have negative 1 over 6 multiply these two terms, right? So we'll get 1 over 12 natural log these big guys, and then negative 1 over 6 multiplied by this guy. So it is negative root 3 over 6 arctangent 2x plus 1. Oh, I running out of space. Okay, root 3. Okay, so far so good. And then I will copy this guy. Okay, 1 over 6 multiply to this guy, so we'll complete the solution. 1 over 12 ln x squared minus x plus 1, and then minus root 3 over 6 arctangent 2x minus 1 root 3, and then I know I will plus c at the back. Oh, I finished. So thank you very much for your watching. I know this video will be quite long, and then I hope you guys will enjoy and continue to support my channel. Thank you. Bye bye.